Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of intersecting linear equations. This is standard 8.9a in the great state of Texas, and we are using item number 13 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we get two lines that are graphed. We simply need an ordered pair that is the solution to the systems of equations. Now, if you know what a system of equations means, this is a really simple problem. So let's take a look at what that means. Right? We've got system of equations. That means they share an x and y because they can be graphed on the same coordinate grid. And that means there's a solution where they intersect. That solution is going to be the intersection. It's going to be the x and y coordinate that actually works in both equations. Right? So let's take a look at this line right here. We can actually write an equation for that line. I'll write it in red here. Right, first we need to find the slope. Right, so let's find x1 and y1, x2, y2. So that's going to be 3 minus 7 over 8 minus 0. Right, so that's going to be negative 4, 8. So that's going to be negative 1/2. We know the y-intercept is 7. Right, so if we want to say this one is y equals negative 1/2 x plus 7. That's the equation right here. Now if we wanted to do the same thing for this one, it's going to be a positive slope because it's moving up from left to right. It's going to be a steep slope, right? So we'll make this the x1, we'll make that the y1, we'll make that the x2, make that the y2. So that's going to be 0 minus negative 5, so that'll end up being a plus 5, right? And there'll be 2 minus 0. So that's going to end up being 5/2. Okay, we do have an x or a y-intercept at negative 5, so this is going to be y equals 5/2 x minus 5. So that's this equation. So what we're looking for is what is an x and y value that would make a true statement in both. Well, hopefully you noticed we have an intersection right there. They cross at an x value of, let's see, 1, 2, 3, 4, and a y value of 1, 2, 3, 4, 5. So theoretically, this 4, 5 is going to be our solution. We see that down there at the very bottom. But how do we know besides visually, right? Visually we can see it, but sometimes we don't get that visual. Well, let's plug that in. Should make a true statement 4, 5. So I'm going to take this first one, y equals negative 1/2 x plus 7. I'm going to plug in that 4 and that 5. So that's going to be 5 equals negative 1/2 times 4 plus 7. 5 equals negative 1/2 times 4 is going to be negative 2 plus 7. 5 equals 5. So that's a check. Let's see about this bottom one right here. Okay, this is the y equals 5/2 x minus 5. I still want to plug in that same x and y coordinate, x of 4, y of 5. So my y is 5, 5/2, my x is 4, minus 5. Okay, so we need to simplify this here. So that's just going to be a 1, and that's just going to be a 2. So now it's going to be 5 times 2. So 5 equals 5 times 2 minus 5. 5 times 2 is 10. So look at that. 5 equals 5. There is no other x and y coordinate for this system of equations, right? Two equations. This one right here and this one right here that can be graphed here. There's no other coordinate pair that can actually make both of those a true statement. It's going to be that 4, 5. If it's graphed like this, you're simply looking for the intersection. You can identify it in less than 30 seconds. Sometimes you just have the equations, or you might have tables, and you got to do a little bit more work. Either way, our answer here is going to be D.